Today is day 28 of 30-day lead coding challenge, and the problem is to find the first unique number. So a stream of numbers will be coming, and at any point of time when you are asked what is the first unique number, so there is a notion of sequence here. So the number which came first and it's unique, you will return that value. So let's see an example, then it will be more clear. So you have to implement three functions, and this is the constructor of the class first unique. So initially you will be given a vector of numbers, and we will run through this example, then all these three APIs will be more clear. So you will create a data structure, whatever data structure you are maintaining for storing the stream of numbers. So you will create that using this initial list, and this will be in the constructor. Then you can be asked at any point of time, give me the first unique number. So you will see that this number came first, then this number came, then this number came. So till now, let's say you have 20 numbers that has occurred. So you will see this is not unique, this is not unique. It has occurred somewhere else also. So you will see, yes, this number is unique. So you will return the first such number. Here, order is important. You have to return the first unique number and not just any unique number. And then you should write a function for adding a new value. So till now you had, let's say, 20 numbers, but client may ask you to add 50, add 60. So you will add two more numbers to it. So now it should become 22. So you should have these three. Let's see an example. So first unique, this is the constructor. And these are the functions list, and these are the corresponding argument list. I have exactly copied it from the LeetCode, the format they have given. So first unique 235. So you will create, you have 235 now in your data structure. Then show first unique. All three are unique. So you will show the first one, which is 2. So this will not return anything. It will just store the numbers. So output is null. When you call show first unique, and it does not take any arguments, so this empty bracket. So at this point of time, 2 is the first unique number. 3 and 5 are also unique, but they are second and third. So you return 2. Then we say add 5. So we add 5 to it. Now you see 5 is no more unique. And then we call show first unique. So still 2 is the first unique. Then we add 2. We add 2 here. So 2 is also not unique now. Now the only unique is 3. So when we call show first unique, we return 3. Then we call add 3. Now we have added 3 also. So none of the numbers are now unique. And finally we are calling show first unique. So if no number is unique, then you return -1. Otherwise you return that number. Now let's see how we will proceed this. How we will store our numbers, what data structures we will use, and how we can achieve it. So this first function is obviously order n time, and this is not important. This is the constructor. Whatever list is given, you have to store that. And the thing is that this function, we will try to make it order 1, that is constant time. Whenever somebody asks what is the first unique number, irrespective of how many numbers we have or what order they have arrived, we will do it in order 1 time. And add also, we will do it in order 1 time. So let's see how we will do. So if you have watched my earlier lecture on LRU cache, that concept will be very useful here. We will be using a doubly linked list and a hash map for working with this. And why? You will say that if numbers are coming, why cannot I store in hash map and numbers as key and how many times they have occurred as the value? So first time it occurs, I store 1. 3 also 1. So whoever count is 1, that is unique. then 5 is 1, then second 5 comes, we increment the count to 2, and this way you keep storing in a hash map. So this add part will be fine, it will be order 1, and you are also keeping track of which numbers are unique. But when asked about which is the first unique number, that info is lost. The same problem that we had in LRU cache. There also the ordering was important, the order in which these keys have arrived. Here also that ordering is important. There are many unique numbers here, but ordering is lost. So that's why we will need another data structure linked list where the numbers will be in the same order. And whenever number is unique, we keep appending it to the doubly linked list, and also the key and the corresponding node pointer. And in C++, we had used the iterator, list iterator, which was serving as a node pointer. So we will here do the same thing. We will have a hash map. Key will be this key itself, an integer, and the value will be a pointer to a list node. And why do we need pointer? Because we will be deleting certain nodes from the linked list. And in order to delete a node, if the node is in the bit in between, if you are not storing the actual position, then you will need to iterate the whole list and go there and then delete it. That will be order n time. But if you are storing the pointer itself, let's say I want to delete node 3, then what will I do? I will see what is the previous of 3. This is the previous of 3. What is the next of 5? This is next of 5. So I will make the next of previous point to 5 and previous of next point to the previous node, and we get rid of this. So this node is gone. So whatever was the list still remains there. Only that next of 2 is 5 and previous of 5 is 2. So this node is deleted, and it will be done in constant time because we do only a few pointer changes. That's all. That's why we will be storing the node pointers here. And now let's come to why we need a list. So whenever we find a unique number, a unique key which has not occurred, we will append it to the list. So 2 came, we appended to the 2 to the list, it was empty, and also in the map we stored 2 and corresponding position. Let's say P2 denotes the position of node 2. This is a pointer. Then 3 is there, so we added 3, and same here, P3. Then 5. So whenever we are asked, we will return from the beginning of list. Whatever is the beginning of the list, we return that value as the first unique. And whenever any duplicate comes, till here it's fine. Now I see that 5 has already occurred, and I want to insert 5. So what we will do, we will see that 5 is not unique because we will check if 5 exists in the map or not in constant time. I will see that yes, there is a pointer here, a valid pointer. And if it's end, in C++, if we iterate any container, then this end iterator denotes one position beyond the last element. So it's not pointing to any element of the container, but after the container. And similarly in Java, we will store null here. So we will check if this is a valid pointer, neither int in C++ nor null in Java. Then that means it's unique till now. We have not yet encountered duplicates of this, but now we have a key which makes it duplicate. So what we will do, we will make this pointer null. So why null? Why not delete this from the map? Because if we delete, we lose track of 5. Next time 5 occurs, we will think that it's unique because it's not in the map. So we don't remove from the map. We just set its pointer in the list to null. So this way, both purposes are served. If key exists, that means it has already occurred. If it's null, that means it's already marked duplicate. We don't need to do anything. So when 5 occurs, it was some valid pointer, so we make it null, and we also remove from the list. So now list has just 2 and 3 now. Now next time 2 occurs, we see that yes, 2 is there. Now we see its value. It's a valid pointer. That means it's in the list. So we have to delete it from the list. We only store unique numbers in the list. But in map, we have all the numbers. Only their value will be removed. If it's a duplicate, value will be null. So now we want to insert 2. So 2 we will make it null. We will remove it from the list. So list has now only 3. If we want to find the unique, we will return this because head will now point to here since the head has been removed. So we will return 3. Then we want to insert 3. So we will see 3 is there in the map. Yes. What is its pointer? It's a valid pointer. That means it's in the list. So we will remove from the list. Now list is empty and we will also make it null. Now if we ask what is the first unique, we will see that list is empty. So we return -1. So I hope you understood it. It's very much similar to the least recently used case logic. And now let's implement it in C++. And then we will modify our C++ code for implementing it in Java. So let's begin. So this is the exact same example that I had shown here. These are a few more examples. All are trivial cases only. There is nothing, no surprises here. So it says use doubly linked list with hash map pointers, same as LRU cache logic. So let's begin. What we will do, we need a few member variables, just like LRU cache. So we will have unordered map. First value will be int. Key is an integer, the actual key, and its value is a list iterator. And then we will have a list. Let's call it keys. So let's store it in our data structure, whatever we just saw. So if map.find n not equal to map.end, then this means key is already present in the map. It's present in the list or not, we don't know. If it's present in the list, that means it has occurred once till now, before this number. If it's not in the list, that means it has occurred multiple times already. So it's in the map. So map n, this will return us the actual iterator. It may be end of the list or it may be a valid value. Key is present in list. So if it's present in the list, we have found a second instance of this key. So we need to remove it from the list and also update this iterator corresponding to this key in the map. So we will do keys.erase, and here we pass the iterator. Since we are passing the iterator, this will take order one time. It doesn't need to search that key. And also map n equal to keys.end, and this end denotes one pointer beyond the last node. So it's not pointing to any valid node of the list. And if it's already deleted from the list, we don't need to do anything. So there is no else condition here. But there is a else condition here, that is, if it's not present in the map, then that means first occurrence. So this is occurring for the first time. So we need to insert in the list as well as map. Keys dot push back. In the list we add in the end. And now we will need the iterated to the last element. So the way to do, there may be other ways, I am not aware of that, but I will first get the end and then I will subtract the end by 1 so that it points to last element. You can write auto keyword here. I am just trying to be more clear what this variable denotes. So now this iterator points to the last element after we did minus minus and map n equal to it. And we have taken care of this part, the constructor part. And then let's implement the so first unique. So this should be very simple. If the list is not empty, if list.size is greater than 0, then we return keys.front, else we return -1. Now let's implement the add. This will be very similar to this thing. In fact, we could have implemented add and we could have called add here, but let's write it again. We want to insert this value. We check if it's in the map. If it's in the map, we check whether it's already deleted or not from the list. So both the constructor and add logic are same. You can use add function directly here. Let me use it. Add then value. So this makes it much simpler. So let's run it and let's see if it works. Null to null. So looks like our answer matches with this. Let's try the other test case. So this also seems to be correct. Both expected and our answer are same. So let's submit it. And the solution is accepted in C++. Now we will write it in Java. And it's not that big. If you see it, very small. The main logic is in the add. And other than that, we are not doing anything. If it's present in the list, we are returning. And in the constructor, we are adding all the elements of this vector. So main logic is in add. So make sure you understood what we have done here. And the problem will be slightly difficult in Java because in Java, it does not give, we cannot delete a node from a linked list using a pointer. We need to iterate the list and then delete it. So that would make it order n. So that's why we will implement our own doubly linked list. We will need doubly linked list for this. We cannot do with singly linked list. because for deleting you need the both previous pointer and next pointer, so that for previous, next of previous, you make that the next pointer, and the previous of next you make to previous, and you need to get rid of the current element. That's why you can easily do it with doubly linked list. So let's implement it in Java. So first of all, we need a implementation of linked list. So you would have already done it multiple times. This part is not the main thing, the main part of this problem. List node. So I will create a list node, and this should have next, previous, next, then previous, and val. I'm not making it generic. It's currently valid only for int, because we need int for our problem. You can make it even more generic. And then a constructor. Let's make the member variables with underscore. So this is the doubly linked list class. This also we need. So we will keep track of head and tail both. Because in C++, you remember we needed the last element pointer where we did iterator dot end, list dot end, and then we subtracted one. So we need head and tail both. So when it's empty, both will be same. Head and tail will be pointing to same thing. So if here we set the next of head to tail, and if that is the case, then that means there has been no element inserted in it. It's empty. And then we also need to remove void and here we implement the removal logic. So previous node equal to node dot next also. So now we have previous, now we have next, and previous next is next. So previous dot next equal to next, and next dot previous equal to previous, and we are done. We got rid of the intermediate node. Now we need a function for adding it to the end of the list. We want to add this key num, so we will create a node first. Next of last node is node, and node dot next is tail. And since it's a doubly linked list, we also need to set the previous of tail to node. And the previous of this node and now we are done. We also need to return it. Do we need to return anything? Let's see if we need, we will make it return. And now we will create the two variables just like we did in C++. So private mydll, same name, keys, and private map integer and list node map. Now the initializer. So now we need to insert this. Let's implement the add first, and we will use that here. So if the value of, so first this key already exists in the map, that means this instance, whatever we are trying to add, will make it duplicate. And then we check if the value is already null, the key, the value of this key is already null, then that means it has already been marked duplicate and also removed from the list, because this value denotes nothing but the pointer in the linked list. So if it's not nil, that is, it has occurred just once, this is the second instance, then we need to make it null. And we have removed it from the list. Map dot put value and null. And else case is not required. It's already marked duplicate, already deleted from the list. Just ignore everything. Else, that is, it's not present in the map. So this is first instance. So we need to add to the map and also to the list. And after appending, we need to add this pointer to the map. So we will make it to return the list node. And now after appending, it will return the list node. And then we will put this to map. And we are done. And here what we will do is keys dot is empty, return -1, else return So here the logic is exactly same as C++. You can see it, you can map it one to one. Only thing is that here we needed a doubly linked list, for which we created our own implementation of doubly linked list. And let's try it if it compiles. Line 26. Again 48. (56) and 66. Keys is the list, not hash map, and this looks like this returns the head, so we need to call the value on that, not the node itself. Dot val, and other one is this map. So it gives runtime error and there is no output. So even the first one was not run. So let's see. So we know that the main logic is in add. There is nothing here. We are just calling add. Here there is no chance of error. And in add we are calling remove. Keys dot remove. Remove previous. This seems very simple. Two nodes. We are making its next this, its previous this, and middle node is gone. And then we are doing append. And we are returning the newly appended node. Created node, previous, the tails previous, that is the last node. And then we are doing append. And we are returning the newly appended node. Created node, previous, the tails previous, that is the last node. And then we are doing append. And we are returning the newly appended node. Created node, previous, the tails previous, that is the last node. and then its next is the current node, the node that we created, and the current node's next will be tail. That's correct. And tails previous will be current node, and previous we don't need to change the previous of previous. That is now the second last node, but the node's previous is the previous node, the node that was earlier last. Now we have appended this node. So hopefully this should work. Okay, this works and both the answers match. So let's go ahead and submit. And our solution is accepted in Java as well. So you see that the core logic is very simple. I am not implementing it in Python. It's already a long video. But you can implement or replicate this logic in Java into the Python as well.